right, welcome everyone, and thank you so much for joining us for today's load testing apps in your Azure Kubernetes cluster. We're very excited to have you. Joining us today is an MVP. His name is Roy Kim. I'll give him a quick intro very quickly, but right before we do that, I'll just give a short little housekeeping blurb. I'll put some links in the chat for you to check into today's event, and that just gives you all the links that Roy is about to share. Secondly, the chat window is open and Roy will be looking at them as well and will highlight any comments or questions that you have. He might take them all up at the end or as they go on. So please feel free to use that chat window. We really encourage you to participate in today's session. And lastly, I'd just like to say that please follow our code of conduct, and I'll share that in the chat too, but really just being respectful of your fellow attendees and our speakers so that we can all have a good session today. All right, awesome. So without further ado, I'll just introduce Roy. Roy is a Microsoft MVP who strives to achieve business outcomes with Azure and Office 365. He currently works as a solutions architect focused on Azure, SharePoint, and Office 365. He's also been supporting solutions in Azure for large enterprises, and he's just been doing a lot. He's actually been a 2-time MVP award recipient. He also has a Bachelor of Science in Computer Science from the University of Toronto. Without further ado, I'll stop talking and hand it over to Roy.
Thank you, Eamon. Hello, everyone. Thank you for attending my talk on load testing apps in your AKS cluster. So, yeah, this is basically my bio, and I think Eamon has introduced me very well. But one thing I like to point out is my blog at roykim.ca. I also, if you click into there, you can find my YouTube channel and other social media. So feel free to check it out there. Yeah, I live in Toronto, Canada. So to know kind of where I'm from. Today, the agenda is kind of a quick overview of AKS, and also the type of applications that I've deployed in my AKS cluster and its architecture, and also kind of a load testing tool using JMeter. And then we'll look at different monitoring tools such as Azure Monitor Insights and Grafana to see how that JMeter tool has, put on some load. Okay, so what is Azure Kubernetes Service, right? For those who don't know, right? It's basically a container orchestration service. So if you know like Docker and you use Docker to containerize your apps, especially when it's a multi containers such as in a microservices architecture. So really, the way I like to describe AKS in simple terms is that you can build it out to be your own little micro data center, right? That's all kind of like software defined, right? So it's got its own kind of networking, load balancing, keeping things available, resilient, auto scaling, health monitoring, kind of a DevOps kind of life cycle management for your infrastructure, how to expose things internally and externally, also many security constructs, right? So, and then you can deploy many applications, right? And you have your own little hosting platform, right? So that's kind of the power and beauty behind Azure Kubernetes Service, and it being in Azure. You have two sides, one that's managed by Microsoft and one is kind of customer managed, right? So it is kind of like to describe it somewhat of a platform as a service, but as well there is quite a bit of some kind of infrastructure service where each node is really a virtual machine behind the scenes, but you still shouldn't, although you can access it and but you shouldn't really touch it or configure it. So let the Azure Kubernetes Service kind of handle that. but it is something that is kind of you have some exposure in the Azure portal, the Azure managed side, which is kind of the brains, the scheduler, the control plane of that stuff is kind of in a black box. Okay, so also, I want to mention that if there's any questions, feel free to interrupt me. I'd like this session to be engaging, and really the goal is so that you have some takeaways that you can, further your careers, your projects, right, and and further your knowledge and your capabilities. So feel free to ask any questions. So as part of my demonstration in my Kubernetes cluster, I have these various applications I've deployed, right? So again, it's like you can design AKS to be kind of like a hosting platform, right? So I have these apps called the guest book where you just kind of sign in, data stored in Redis, a book info app, which is an example sample app from Istio, right, which conveys or demonstrates a microservices architecture, a voting app, which uses a MySQL database, and a to-do list app, which goes against Azure's SQL database, right? So, so the beauty here is that you have different programming languages, data stores, and it's all under one kind of hosting platform, and then they can all leverage and share compute resources so that you have a lot of like density, right, like a cost effective use of resources, right, like CPU and memory. So here's a diagram I drew, which kind of shows
Hey,
you know
Roy, sorry to
yeah.
interrupt you. Are you sharing that diagram right now on screen? We are seeing the StreamYard window at the moment.
Oh, okay,
You might
hold
have
on.
to share again and make,
Yeah, I think I have to share, maybe because I'm in
yeah,
full screen mode. Okay, thanks for bringing that up. Okay,
yeah,
let
no
me try
problem.
that again. Um, so bring up share screen. Okay, so here, let me stop the cam. Okay, how about now?
Yeah, we can see your PowerPoint window.
PowerPoint. Okay, I will not do it in presenter mode. Maybe that confuses StreamYard. But okay, so here are my demo applications. Okay, guest book, book info, voting app, to-do list app. Okay, so here's the diagram that I drew up. And so, yeah, let me walk you through kind of the architecture here, right, and the application. So the kind of the light purple boxes are individual namespaces, which are kind of logical like containments, okay, to host your application, right? So the guestbook app, there's really a front end and a Redis. I have a Hello World app, which I'll show you. It's extremely simple, just kind of a one page, just app. Book info app, which has multiple, pods right here in different tiers, like a product page, reviews, service, details, or rating service. The voting app here as well. Okay. Um, and then when we move on to, let's say on the left side, I'm presenting, here how we can have the great flexibility of two ingress controllers, right? One by Nginx and one by Istio. And so really the purpose of an ingress is to handle traffic and route traffic coming from outside of the Kubernetes cluster. Okay, so when you build a Kubernetes cluster, it comes with Azure Load Balancer by design. Okay, whether it's an internal load balancer or a public facing, internet facing Azure Load Balancer. Okay, and so that's where traffic comes through, and the ingress controller, you give it like some like routing rules to say that and also configure such as HTTPS, SSL, DNS, hostname based kind of routing to go to different apps. So for this Nginx one, it's in front of routing traffic to these to Guestbook and AKS Hello World app, where the Istio ingress controller is routing traffic to these two, book info and the voting app. Okay, so that's what that's for. On the very bottom left is the kube system namespace, which is really um, Kubernetes itself. Okay, kind of very system levels. Something you don't shouldn't really touch too much. Okay, especially when you're a beginner. And then at the bottom, I set up a monitoring namespace and Kiali. Kiali is for visualizing your service mesh for Istio, but that's a topic for another day. But I'll go into and demonstrate kind of Prometheus and Grafana. Prometheus being kind of taking telemetry monitoring data, and Grafana takes the telemetry, the logs and metrics, and is a visualization like with graphs and tables, and so you can build visualizations and dashboards, right? Um, and so at the bottom here, because this is part of Azure, you can leverage other Azure services, right? So Azure Monitor, okay, which I'll get into in this talk, and Log Analytics Workspace, which saves some of that monitored data. Azure AD for role-based access, and also Azure Managed Disk to persist data in various disks. And of course, as you know, you definitely need Azure Container Registry to, when you containerize your image in a build pipeline, to store it in here. And then when you deploy or do kubectl, like deploy various manifests, um, to create pods and services and deployment objects, and that will pull your Docker image, right? Your that represent your application, or you can get it from Docker Hub as well. So that's kind of a rundown of what this shows. But the main core agenda of this is to, we have these applications. And there's probably like 4 to 5 virtual machines or nodes, and how do we test for performance, right, and load, um, such that we are right sizing, allocating the right resources um, at the node level, right, like 2 virtual CPUs, 8 gigs of RAM. Also in Kubernetes, you can assign or allocate and put hard limits on the amount of CPU and memory, right? So for the product page, you can say, oh, let's give 25% or 20% of a, like a core, like a virtual core, right? Virtual CPU, right? And give it a hard limit of like half a core. So we need to test, you know, are those settings appropriate, right? Also, we want to test auto scale at the pod level, okay, where this product page, it can, once it detects a lot of load, that it can spin up another pod, okay, or 2 or 3, so that it can be fairly resilient and auto scale. And also auto scaling at the node level too, because Azure Kubernetes Service has a feature called autoscale. If all the nodes, let's say 4 nodes, are pretty busy and it needs room to generate more pods, then an additional node will be automatically provisioned, and that I will kind of demonstrate as well. I'll pause right here if there's any questions. Is anything in the chat?
Hi, Ray. So usually there's a 30-second delay between what you say and what the audience is hearing.
Oh yeah, that's right. Yes.
So yeah, so people will now slowly start adding comments if they have any questions. So I'll definitely, if you wanted to switch to the StreamYard window, I'll interrupt you too if there's something that comes up.
Okay. Yep. Interrupt me anytime. Okay. So Well, let's switch over to the browser. Okay, so let's see here. Um, let's see here. Okay, let's look at some applications. So let's see here. So okay, I'm hitting refresh. So here's the book info app. It's kind of loading here. Let's see here. So as I hit refresh, you'll see that sometimes there's a star or no stars, a red star or a black star. There's really three versions of this review service. Okay, and I'll get to that in a minute. This is that Hello World app. All it is just this one page, right? So this app is the very first, the simplest tutorial in the Microsoft Docs when you're getting to know Azure Kubernetes Service. Here's a guestbook app which has that Redis, data store, right? And you just sign that's stored in Redis. Um, this here's loading is a voting app, okay? And you can share this link to other people, and it will get your votes, everyone's votes of cats and dogs, let's say. And here's that to do app with point to Azure SQL, and then you can kind of look up the details right here. So that's kind of the various apps, and the key thing is this is all hosted in one Kubernetes cluster. Okay, and let me just show you quickly that Kubernetes cluster. Okay, and go through here. So here we have the Kubernetes cluster. So overview. So here's all the namespaces that I showed, right? So the Hello World app namespace, book info, guest book app, um, etc. Or I even have WordPress. Okay, but in the book info app, when we click into that, um, we can see kind of all the YAML files um, with that, and the various workloads. Okay, so let's see here. Let's pick the book info app as an example. And we have here kind of the various Kubernetes deployments. So these are like what you say, what um, you can refer to as the each microservice. Okay, product page, which is the front end, the review service. There's three versions, but the way it's designed right now, the traffic routing is kind of round robin between version 1, 2, and 3. Version 1 doesn't have any stars, V2 has the black stars, and V3 has the red stars, right? And so that's how that looks like, right? Service and ingresses, which is helping with exposing traffic, storage, and configuration. Okay, storage, going to like manage disks that I shared, um, and etc. And right now, the node pool, right? So we have 5 nodes in the node pool, and they are standard D2 VS3. So that's 2 virtual CPUs, and maybe 8 gigs of RAM. Okay, so that's just a quick overview of the Kubernetes cluster and showing the apps improve, kind of, you know, proving to you that those apps are in this one cluster. Okay, now going back to the slide deck. Um, so so this is just to show kind of how traffic is routed between the product page, version 1, the details, and the reviews microservice, and then traffic evenly balanced between version 1, 2, and 3. Okay, so if I revert back, let's see here. This is so the whole page is the product page. The books detail is the detail service, and reviews. Hit refresh. so slow, then you can see, you know, the three versions happening. Okay. So, so that's how that looks like. Okay. And let's see here. So this is the application architecture, kind of the microservices design. Now let's finally get into JMeter. Okay, so JMeter is a open source tool. You can go to jmeter.apache.org. It's built on Java. Um, so I've gone to know how to use this. It's a bit of a learning curve. It's not as intuitive as you would hope for, but after you get through the learning curve, it's pretty flexible and can be quite powerful. So it's a free download, um, and you can do load tests, performance tests through various protocols, not just HTTP. Um, and there's various modules that you can add to it and extend. So it's pretty neat. So let me show kind of that tool. All right. So as you can see here, actually I had a load test running, but it was running, but let me stop. Okay, clear it. So let me walk you through kind of this setup here. Okay, so when you start out, you create a test plan, right? And with JMeter, the design is very hierarchical. And it for me, it was kind of getting used to kind of how everything is hierarchical um, and how things relate to one another. Okay, so right here is a thread group. Okay, and underneath the thread group is various like HTTP requests that you can set up, right? So at the thread group, you define the key things you define for is the number of threads or users, so virtual users. So I have 500, which is quite a bit. Okay, so then these are simulating users that are kind of clicking away, kind of pretty much concurrently after a period of time. Ramp up seconds, so 50 seconds to get to 500. You know, um, and also kind of looping through these HTTP requests. Okay, um, so I say kind of infinitely, but I do it at a defined duration of 2000 seconds. Okay, so really, you define kind of these three things: the length, the ramp up. You don't want to do ramp up to be like 5 or 10, like that can kind of choke your test rig, right? With this, which right, this is a virtual machine, and and it's pretty beefy. It's got, let's see here, it's performance wise. It's got 16 gigs of RAM. Okay. It needs a lot of memory to do this load test. Okay. 8 gigs was not enough. So, and then you have this play button. Okay, let's start that off. Okay, so there's the timer there. And oh, I should have mentioned here. So in order to add HTTP requests, so in the hierarchical nature of things, if for each node you add a sampler. So in this case, I added an HTTP sampler. Okay, and each one of these that you see down here, I have a sampler to that .NET Core, like that to-do list app. Is this URL right here? It's a GET request. Um, that's kind of the extent of this setup, but you can have HTTP headers, HTTP bodies. There's a lot of options which make it pretty flexible. There's also a guest book as well. I showed you, and so really I'm just hitting the main page of every single app, okay, including the book info app, okay. And then to see kind of results and the kind of the measuring that's going on, you go right click, you add, um, let's see here, listeners. Okay, summary report, aggregate report, even graphs, and I have them down here. So the summary report, you'll see uh, the HTTP requests, how long they're taking, any error rates, throughput, um, etc. Okay, um, kind of view results right here. So, um, you know, the HTTP request. So I guess WordPress is not acting well. Okay, that's okay. Your response time graph, right? So you display a graph. So, for example, the book info app, which is purple, it's the response time is pretty good, is nice and low. The guestbook app is about I think the peak time or peak response time was 18,000 milliseconds, so that's 18 seconds, which is pretty slow, but it came down. So what I'm suspecting here is that the horizontal pod autoscaling has probably responded, and as you can see across these apps, there's a general kind of downward. The response time is improving. Okay, from here to here. Okay, so I'm suspecting that horizontal pod autoscaling is helping out with that. Okay, as the load was increasing. Um, view some like view results in a table format, aggregate reports. This is another type of graph results as well. So and I'm sure through the open source community, there's other more options as well. So that's how JMeter is working. Okay. You can have in JMeter, you can add like logic controllers, like a if controller, looping, while, just like you do in any standard programming language, like for each, right? So let's say you want to have a certain scripted play, right, of your test, right? Simulating, various user clicks or how they're, playing out on a shopping experience, right? Like buying or, adding to shopping cart, etc. Okay. Um, and also one thing's pretty important in your test design is to add, like delay timers or try to time your events. In this case, it's very simplistic. I'm pretty much like very aggressive. Okay, like I just have 500 users, ramp them up very quickly, and off you go. And they're just kind of hitting it very aggressively all at once. Okay, but it's good for situations where at peak, but in terms of test cases and test design, there's cases where you want to do something called the duration test, where let's say it's not very much of a high load, kind of more of a like a medium scale load, but run that through a very long period of time, like days, weeks, to see the effects of a long period. Maybe there's a memory leak that will occur over time, right? And you want to identify that. Yeah, but you won't identify those things if you do those short, but aggressive load tests. So those are things you need to consider. Okay. Um, so let's see here. So that's JMeter. I'll pause for a bit if there's any questions.
None yet, Roy. Let's give folks a couple minutes. If anyone
Sure.
has a question, please leave that in the chat.
Okay. Okay, and so as we're seeing kind of this load test, it's been running for 6 minutes. Just a quick view, you can see that good 60% of memory usage has occurred. CPUs at 30%, but I think this has how many cores does it have? I think it's got like four at least, right? It's pretty beefy. So it's taking up quite a bit of resources. Okay. Um, so when you design for your test rig, that's something you want to consider. Okay, so now let's flip over to kind of the monitoring side, right? Like what are the effects? Okay, and also to see kind of horizontal pod auto scaling. Okay, so let's see here. So where should I go to the? Okay, we go right here. Okay, so we go back to the cluster. Okay, there's a neat little feature called Azure Monitor Insights for Kubernetes. Typically, you have to kind of enable it, choose a log analytics workspace to store that data. So um, what we see right here is kind of at the cluster level, we can see node CPU utilization. A few hours ago, I did a load test cycle, and you can see it all ramp up, even as high as 100%. Okay, let's choose 95th. Whoops. Okay, let's do max. Go back to max. It's more reflective. Wait a minute. Okay, let's refresh there. So okay, there we go. So the blue is the average, and then the red is kind of more kind of the max that was of the capacity. Okay. Um, so you can see that, yeah, you see the trends. Right now, load test is occurring. It's pretty high at this point. Also, memory utilization is pretty flat. Okay. I think these apps are not very memory intensive. Okay. Um, but the node count is something to take notice. Okay, so as I mentioned, there's something called autoscale at the Kubernetes Azure Kubernetes level. So what happens is that we're here. I think it started off as 3 nodes. Okay, and then after a load test, it ramped up to 7 nodes. Okay, and when the load test finished, you know, it wasn't as busy. There's no activity anymore, so it went back to 5 nodes. And as you can see right here, the node count is increasing because we just started a load test. It's at 6 nodes. But if we go down kind of at the pod level, okay, um, we can see the number of pod counts. Okay, so in this case, the pod count started off down at, let's say, I think here around 42, and went all the way up to 120. So there is a horizontal pod auto scaling, right, happening. That is one of the key benefits, that the auto scaling at the pod level is pretty quick, a matter of several seconds to 30 seconds, or on average. Okay, so it can respond pretty quickly, leveraging like container technology, right? Um, and then when that load test died off, that pod count goes down. So one thing to note that's really important is that what influences the auto scale, like the node count to go up, is really the number of pods that can be created in a node. So if all the nodes are pretty much at capacity, like at close to 100%, and there's still nodes, other pods that need to be scheduled, okay, and so that will tell the AKS auto cluster to start provisioning another node, okay, which is not a very quick thing, is not a quick process, like 30 seconds, but it can take a few minutes because it's an actual VM that needs to be created, and then you have to kind of load it up with yeah, your application and bits and all this stuff, right? So that's where a lot of pods, and it's not just your application pods. There could be copies of kind of like Istio and even Grafana or Prometheus, like all these system and operational purposed pods. Okay, and so once it goes down, then that will kick off the auto cluster to kind of scale down its node count. Okay. As you can see on this right side, we do have the pod count because the load test is running. So, um, so we have that coming. Okay, I hit refresh. Uh, yeah, it's a little disjointed data here, but in any case, here in Azure Monitor Insights, we can go down to the node level and get to more details, and we can see the trends, etc. Um, Here's the voting app. We can see by clicking on this. So this is the deployment pod level. Okay. Live metrics. Uh, and we can see various details. And this is at the container level. So the voting app. Okay. Um, and then and this is how you can kind of analyze and troubleshoot and see if you've right-sized your applications here. So we can see this node kind of trending on the red, right? And then we can see which pods or processes are um, taking up resources. So this is kind of, in my opinion, a disadvantage. Like I don't see metrics for CPU memory quite well at this level. Like I don't like the graph or the visualization. It's good to see um, kind of the container limits and some of this information here. So this is where I find Grafana to be better. So let's switch over to Grafana. Okay, so this is Grafana. This in it of itself is also hosted in the same Kubernetes cluster. Okay, and I like a lot more flexible, a lot of granularity that we can kind of analyze. So if I go to the last 6 hours, and it's pretty quick too. It's pretty responsive. So we can see the load test that's happening here, and then so this we're looking at it from let's see here, from a per node. Let's see, voting out. Okay, so this one line is looking at each of the pods. Okay, but we can also filter. Let's say let me pick on product page v1 of that book info app. We could kind of see how that's acting. Okay, it's been pretty even here all across. Okay, let's check another one. Let's do all. Let's see, let me refresh. Okay, let me pick on. Whoops. Okay, I'm trying to get at one of these lines. Real AKS node. Okay. So, okay, these lines are, I think they represent the nodes, okay, which have more fluctuations, okay. We see disk usage, kind of I/O, so a lot more details here. So this is a dashboard that you kind of get from the community, the Grafana community on the website. And then we have other dashboards. So let's see here. So you can go on the website here and search for dashboards, and um, it's pretty easy. You just get the ID and you import that ID into through this process. You import, you stick in the ID, and then it just knows how to fetch that. Very easy, very easy. Um, let's see what else here. So other visualizations here to show um, kind of uh, kind of at the node level, CPU and memory usage, pod usage. Let me let's go 6 hours. See how that looks. So yeah, we see more kind of variation here, and then you can filter. So just to note, some of these dashboards that come, like they do come with deficiencies. Okay. For example, this selector is not really working. So, but you can always edit it and try to see what you can do to kind of make it better for yourself. Okay.
Hi, Roy. We actually do have a question in the chat by
Okay.
Rag. He
Oh,
asked,
awesome.
I would like to know how autoscale works. Are they scale up according to load?
Yeah, good question. So autoscale works by okay, so yeah, it's by load. Okay, so let's see here. I think I have a slide for it. Okay, so there's two levels of autoscale as I mentioned. One is horizontal pod autoscaling, which I think takes precedence, and then there's cluster level. So by node, right? VM nodes. Okay, the pod autoscaler right here, um, let's say, okay, you have to define a metric and a threshold, right? In this case, I've created a horizontal pod auto scaling kind of Kubernetes manifest, like an instruction to configure it such that once the target is the CPU usage is 50%, of the kind of the allocation, right? Um, I've given it. So once it hits the 50% or more, then create more replicas for that. Okay, so in this case, we're here. So we see here like an event log, right? We can see new size um, has occurred. So so initially is new size 1, okay, and then the horizontal pod auto scale kicked in and you get new size 4, okay. Reason is the CPU resource utilization hit above target, which is 50%, but it was still very a lot of load, so it increased it even further right here. So um, the max replicas I've defined is 5, and the current number is 5. So a total of 5 replicas. Okay, so keep in mind that let's say a node or all these nodes together, they're kind of saturated with pods, okay, because they're demanding CPU and memory resources. Then what will happen is the autoscaler will kick in. The autoscaler does not work by CPU or memory usage thresholds. It's more about the pod scheduling, right? It's more about wanting, you know, delivering on resources to support the creation of pods. Okay, so once that is saturated, then the autoscaler will kick in and scale out. Okay, there is no scale up. Okay, and that's the same pattern with many cloud systems. Okay, or that I know of, like Azure App Service. Only scales out. VMs scale sets, they scale out. They don't scale up. So that's kind of the process and the flow between pod auto scaling and cluster level auto scaling. Hope that answers your question.
Hi, Roy.
Okay.
There's just a follow-up question as well that says, if it will scale up according to load, then how many VM systems will it take to scale up?
How many VMs will it scale out? Um, it will scale out to basically almost as much as it's as needed. Okay. Um, let's see here. Let's walk through that configuration. So, but I think you can set a max, okay? Because yeah, you don't want your system to run away and create like a huge number of nodes, okay? So we go into this node pool, okay? Nodes configuration. Let's look for that auto scale functionality. Um, let's see. Okay, where was that? No pool. Scale node. This one. So here you can, okay, auto scale. Okay, you can do either manually or manual. So as you can see here, you can define a node count range. In my case, I set the max to be 8. Okay, but from a system level, by design, Azure Kubernetes, Microsoft is only allowing up to 100. Okay, so that's kind of the max threshold. You can increase it, the min and the max, in with this configuration setting. I hope that answers your question.
Yep, no more follow-up questions for now, Roy. Thank you.
Okay, thank you. No, that's that's great. So, uh, to kind of wind down, again, here's the Grafana architecture. It's based on the Prometheus server that collects the telemetry, and Grafana just presents it. Okay, again, here are examples of visualizations I've used on projects before. I built the dashboards. It supports alerts as well. You can build your own queries in this case, where you're kind of seeing the rate of CPU usage filtered on the namespace of guestbook app over a 1 minute kind of 1 minute kind of window of averaging it out. Um, Azure Monitor for containers, as we saw. So to wrap up, I just want to open it up for further Q&A. Here's my email address as well for any questions. I hope that you guys have come away with something that you can take to your workplace, your personal projects, learning projects. So
Perfect. Well, thank you so much, Roy. Let's just give a couple more minutes for folks in case they have any questions. If you'd like to turn the camera on, that's fine too. All up to you. And let's just see if anyone has any questions. All right, perfect. It's not looking like we have any questions in the chat, which is all great. If you do have any more questions, feel free to reach out to Roy on those links that he has shared on the screen. And if you have any questions, we can answer them later on as well. You can leave a comment. Oh, I actually did just get a question. So, Roy, we have a question by Vic Perdana who says, how do we know if pods are right sized?
oh, okay. Yes. So okay, by using like these tools right here. Um, okay, let's see here. What's a good? Do I have it right here? So there should be a okay. So as you do your load test, one thing is let me go to Azure Kubernetes Service. Let's see here. Okay, so as you do your test, okay, one thing is let's see here. Go to nodes, controllers. Let's pick on maybe this is. Let's see here. Okay, let's pick on this one. Hopefully this is a good example. So first you need to know its allocation, okay? So we have here this WordPress kind of pod or deployment really. It's got a request of 100 millocores. That's really 10% of a core, okay, with a hard limit of 200. Okay, so that's what it's allocated. And then memory and same thing, memory request and memory limits. This is the request and the limit. Okay, so as you do these testing tools, um, you can see right here kind of its usage, right, in that point, in various point in time. So you can see here the usage hit 177 millicores. Okay, if you find that that's a bit high, then you may go back to your Kubernetes manifest and increase that usage, right, to from let's say 100 to 150. But in this case, it didn't really hit the limit. So I think in this case it's fine. Or you want to increase the limit to let's say 250 or 300, but I generally recommend to keep them around, 50 to 100 millicores, the request. Um, and so that's where your load test comes in, right? And you want to, at different points in time, if you feel like you're simulating peak load, and then you will kind of measure and then kind of make your judgment on, okay, did I give it the right initial allocation, like request? Did it hit the limit? Is my limit too conservative? Also, you can balance that out with horizontal pod autoscaling. That, okay, well, let's say if the usage hits 80%, um, instead of increasing the limit, you may do horizontal pod autoscaling, right? So I generally like to leverage scaling out than keeping very high limits to be safe. Because if you have a high limit for a lot of your pods, that may um, confuse or not confuse, make it more challenging for the autoscaler to kick in. Okay, because the autoscaler kicks in by basically the pod scheduling, right? Demands. Okay, that's my understanding, as far as I know. So you can also use Grafana as well. Let's see here. What was it? Which one was a good dashboard? So I don't know if I have a good one right here. So cluster CPU. So right down with this, you can get to the kind of the pod level. Okay, which this is. I was just having a hard time pinpointing one. Let's see here, this one. Here, I'm not sure if this is a good, we'll get you the details if I double click on it. Um, I think this probably is showing millicores, okay? Um, but in this case, it doesn't show you what was the set CPU requests and limits, okay? So for me, I use both Azure Monitor Insights and Grafana to get different types of perspectives and make those judgments, right? Or to find out the right sizing. It's very much art, as is a science, to be methodical and scientific, but also making your own design decisions on how you want to massage, um, your thresholds and how you want to route right size and auto scale. So hopefully that answers your question there.
Perfect. Thank you so much, Roy. All right, since we don't have any more questions in the chat, we can wrap up. Thank you so much for joining, and thank you for your session, Roy. So the recording will be available after the session. You can just refresh the page, and it should be available right away. And thank you so much.
Okay, thank you. Thank you,
Bye,
everyone. Have a
everyone.
good night. Okay, bye.